All right, welcome to The Explainer. Today, we are tackling something that's, absolutely central to programming, control flow. We're going to break down how you can make your JavaScript code a whole lot smarter, how to get it to make decisions, repeat actions, and basically become truly dynamic.
So let's just jump right in with a really important question. You see, by default, code is kind of dumb. It just runs from the first line straight to the last, no questions asked. But that's not what we want, is it? We need our code to be able to look at a situation and actually decide what to do next.
And this right here, this visualizes the difference perfectly. On the left, you've got that straight, rigid path we were just talking about. But on the right, now that's smart code. It can actually pause and ask a question like, hey, is it raining? And then choose a completely different path based on the answer. That is the whole idea behind control flow. It's all about giving your code these forks in the road.
Okay, so how do we actually give our code that kind of decision-making power? Well, we use a set of tools called conditional statements. You can really think of these as the absolute bedrock, the fundamental building blocks for making your programs intelligent.
So what are they, really? Well, at their heart, conditional statements are basically just bouncers for your code. They stand at the door of a code block and say, hold on, you can only get in here if this one specific thing is true. It's all about that true or false check.
Now, the first and most common tool you're going to reach for is the if statement. It's super straightforward. It just asks a simple question. If this condition is true, then and only then do this thing. It's your number one way to create one of those forks in the road.
But wait a minute, that brings up a pretty obvious question, right? What happens if the condition is, well, false? The code just skips right over that block. And that's not always what we want. For our code to be really smart, it needs a backup plan. It needs a plan B.
And that is precisely where the else statement comes in. It's the perfect partner to if. It creates that classic if this, then that, otherwise, do this other thing scenario. It's the plan B. This way, your program is never left guessing. It always has a clear path to follow.
Okay, but what if wife isn't just a simple yes or no? What if you've got multiple options? Well, that's what else if is for. It lets you build a kind of logic ladder. You can tell your code, first, check this. If that's not it, else if this is true, do this. If not, else if this other thing is true. You get the idea. You just go down the ladder until you find a match.
And while you can build a really long ladder with else if, just look at this comparison. It can get kind of messy and hard to read, right? For those times when you're just checking one single value against a bunch of different possibilities, the switch statement is your friend. It's just so much cleaner and way more organized.
All right, superpower number 1 unlocked. Our code can make choices. Now for the second major superpower we need, repetition. How do we get our code to do the same thing over and over again without us having to copy and paste code 100 times? That, my friends, is the magic of loops.
Seriously, loops are the absolute workhorses of programming. It's all about being efficient. Think about it. Instead of writing the code to process one item, then copying it for the second and the third, you just write the logic once and tell the loop, hey, run this 10 times. It's a ridiculously simple idea, but it changes everything.
Now, this table is basically your cheat sheet for picking the right tool for the job, and it really comes down to what you're trying to do. Do you know exactly how many times you need to repeat, like 10 times, 100 times? That's a job for a for loop. Do you need to just keep going as long as some condition is true, like waiting for a user to click something? That's a while loop. And that do while, that's for the special case where you have to run the code at least once, no matter what.
But sometimes you need to get out of a loop early. It's like an emergency stop button. Imagine you're searching a huge list for one specific name. Once you find it, why keep searching, right? That's when you use break. It just yells, stop, and kicks you right out of the loop to whatever comes next.
And then there's the other side of the coin, continue. This isn't an emergency stop. It's more like a skip button. It doesn't kill the whole loop. It just says, you know what, I'm not interested in this current item. Let's just skip the rest of the steps for this one and jump straight to the next one. Super useful.
Okay, so here's the really crucial part. We've talked about these two separate toolkits, right? Conditionals for making choices, and loops for doing things over and over. But their real power, their magic, happens when you start putting them together. That's when your programs go from simple scripts to something truly interactive.
And this simple guessing game is the perfect example. Check out how all the pieces fit. You've got a while loop that keeps the game running over and over. Then,
Inside that loop, you have your decision maker, that if-else-if-else block that checks the guess. Is it too high, too low, or just right? And when the guess is correct, what do? We use break to bust out of the loop and end the game. See? It's all of our tools working in harmony.
All right, let's do a quick recap. We've just covered a ton, but what it boils down to is that you've just unlocked some serious superpowers for your code. You now have the ability to be the director, to tell your program exactly which path to take and when.
So here are the big takeaways. Conditionals, your if, else, switch, they're all about making decisions. Loops, your for, while, they're your workhorses for repetition. Break and continue give you that fine-tuned control you need inside those loops. And the most important thing to remember? It's when you combine all of these that you start building truly dynamic and powerful programs.
And at the end of the day, this is why all of this is such a game changer. You're no longer just writing a simple to-do list for a computer. You now have the tools to build real logic, to create things that can react and adapt. So the question really isn't about how to write the code anymore. It's about what you're going to build with it first.